Today we will discuss example 5.2 space Jacobian for special triple RP chain, revolute joint, revolute joint, revolute joint and prismatic joint. This one is revolute joint, this one is revolute, this one is revolute and this one is prismatic joint. Figure denote the ith column of Js of theta by Jsi is omega si Vsi. Omega is angular velocity and Vsi is linear velocity. This velocity, if you want to find, we will consider body's origin coincides at fixed frame origin. You have to understand this. And the adjoint transformation of Ti minus 1 matrices are implicit in our calculations of the screw axis of the displaced joint axis. See the figure. This one theta 1 displacement, this one theta 2 joint 2 and joint 3 theta 3. This one is prismatic, say theta 4. This one, consider this one is fixed frame origin, say Q1. This one is x cap, y cap, z cap. Here, this line, this line, this and this. This one is Q2. So if we rotate this joint about this axis, we can consider this point also. Direction is same, z direction. Now omega s1 for this joint. Consider initially they are at all theta 1 0, theta 2 0, theta 3 0. Then after we are rotating L1 theta 1 and L2 theta 2 with respect to this one. So omega s1 is 0, 0, 1 suppose, and q1 this one is fixed frame origin 0 0 0. So this point velocity, because the position vector is 0 0, so vs1 is 0 0 0. And for this joint consider this axis. So if we consider body's origin here, so if this one is q2, then this one is minus q2. So omega s2 cross q2 gives this velocity. So omega s2 is 0 0 1 and q2 is L1 cos theta 1, x coordinate, L1 sin theta 1, y coordinate and z coordinate 0 because it is in xy plane, this q2. So vs2 is, according to the definition, we will consider the body's origin coincides with the fixed frame origin. And what about the linear velocity? So Vs2 is omega s2 cross minus q2 because of if this one is q2, then this vector is minus q2. So actually omega s2 cross minus q2, so minus sign is here, and if we cross product, if we take cross product of these two, we get, you can check, L1 sin theta 1 comma minus L1 cos theta 1 comma 0. And third, omega s3 is 0 0 1 q3, that is this coordinates. It is in xy plane. So x coordinate of, according to our previous example, L1 cos theta 1 plus L2 cos of theta 1 plus theta 2, and y coordinate is L1 sin theta 1 plus L2 sin of theta 1 plus theta 2 comma 0. Here also, if this is rotated by, then we will consider q3 position vector, this one. So minus q3 is this. So vs3 is minus omega s3 cross q3. Actually omega s3 cross minus q3. So minus omega s3 cross q3. We take cross product and with minus sign, we get this one as x coordinate L1 sin theta 1 plus L2 sin of theta 1 plus theta 2. Y coordinate is minus L1 cos theta 1 minus L2 cos of theta 1 plus theta 2 and z coordinate 0. Since the final joint, this one, is prismatic, omega s4 is 0 0 0 and the joint axis direction is given by vs4 is 0 0 1. So the space Jacobian is therefore for first joint 0 0 1 angular velocity and linear velocity is 0 0 0. For second joint 0 0 1 angular velocity, linear velocity is L1, this one L1 S1 minus L1 C1 0. So L1 S1 minus L1 C1 0. This is long term, so we have used symbols. 0, 0, 1 angular velocity for third joint, and this one, this one is x component of velocity. It is written as L1S1 plus L2S12, symbolic. S12 stands for sine of theta 1 plus theta 2. And this one is y component, minus L1C1 minus L2C12. Cos of theta 1 plus theta 2 is denoted as C12. So minus L1C1 minus L2C12 and z quantity 0. And for the fourth joint, prismatic joint, so no angular velocity, 0, 0, 0. But linear velocity is there in z direction, so 0, 0, 1. This is space Jacobian. Okay.